What we're looking at today is dealing with properties of radicals. So what we're doing today, tomorrow, and Wednesday is going to be all revolving around these properties of radicals and exponents. Now this first page here is dealing with properties of exponents, rational exponents, and these here are all stuff that you've done with, we've worked with before. So the first one is product of powers. Well, if we multiply two things that have the same base, we add the exponents. The next one's powers of powers. Whenever we have a number to a power, the exponents multiply together. Power of a product, two things multiplied together to a power, both of them will be to that same power. Negative exponents. If we have a negative exponent, we can move it from the numerator to the denominator or denominator to the numerator. Anytime we go across that bar, the sign will change. Then everyone's kind of favorite, the zero exponent, anything to the zero power is always 1. Quotient of powers, whenever we divide like bases, we subtract the exponents. And the last one, power of quotients. Whenever we have something being divided to an exponent, both of those are applied to the same exponent. And these are kind of our properties of exponents. Now this is the first real thing we're going to fill in, simplest form. There's 3 main things that we need to note that it is in simplest form. No radicands have perfect nth powers as factors other than 1. And what this means and what this is talking about would be like the square root of 4. Well, the square root of 4 is what? 2. We can simplify it. So if we can take that nth root, if we can reduce it down, then we need to for it to be in simplest form. And really, so again, that's saying we can't leave the square root of 4 as an answer. We have to simplify it. Now the next one. No radicands can contain fractions. So we can't have something like this here. We can't have a fraction inside the radical. And no radicals can appear in the denominator of a fraction. Do we have these 3? Yeah, I think some are still rising. So these here are really our checklist to make sure it's in simplest form. Because if it is, none of these will be left. We good? Okay. Use the property of rational exponents to simplify. So we look at the first one here. We have 7 to the 1/4 times 7 to the 1/2. Because the bases are the same, we can add the exponents. So it'll be 7 to the 1/4 plus 1/2. Well, we can do that in a 1/4 plus 1/2 in a calculator. That'll add them together. But if we're wanting to add them together, we want the bases to be the same. So we can change 1/2 to 2/4, which will give us 7 to the 3/4. Now, just typing in 7 to the 1/4 times 7 to the 1/2 will not always give you the answer that you want, because it's going to most likely give you a decimal. This will give you a decimal answer. But we can type 1/4 plus 1/2 into the calculator and get 3/4. And that there is our answer. Now, when we look at this here, there are no radicals in the denominator. The nth root won't simplify because the numerator of it's not bigger than the denominator. We can't reduce it down. That is as simplified as it gets. That would be our answer. So any questions on this first one here? Okay, let's look at the next one. 6 to the 1/2 times 4 to the 1/3. Well, that there is a simplified, we can't multiply those two together because 6 and 4 are not the same. They are not like bases. But what we can do is we can apply this power to both. So what we have is 6 to the 1/2 to the second times 4 to the 1/3 to the second power. Because we can apply that second power to both terms. Any questions on this here so far? Now, powers of powers multiply, so here we're going to have 6 to the 2 times 1/2 times 4 to the 2 times 1/3. Well, 2 times 1/2 is 1, and 2 times 2 1/3 is 2/3. And I have to rewrite that. So we have this here. Now, depending on how it has it, this here they might say is going to be the answer that you want. This is the final answer. Now, the reason I say might is because, well, 4 is the same as 2 squared, because we could rewrite 4 as 2 squared. And again, powers of powers multiply. So we had 6 times 2 to the 4/3. Now this here, again, is where this would not be simplified, because no radicands can have perfect nth powers as factors other than 1. Because the numerator is bigger than the denominator, what that's saying is that there is a perfect factor in there that we can simplify out. Because what this is saying, marker, what this is saying is that I have 4/3. Well, that's the same as 1 and 1/3. That I have 2 3/3 and 2 to the 1/3. Because I have 4/3, I do have a whole we can simplify out. And here, 6 times 2 would give us 12 times 2 to the 1/3. So we could simplify that there even further if we turned 4 into 2 squared. Now, most of these on the assignments, they're going to give you multiple choice. They're not going to give you a fill in the blank, which is a little bit nice. Any questions on this here so far? Okay. The next one's a little bit easier than that one. 4 to the 5th times 3 to the 5th to the negative 1/5. Well, I can't multiply the 4 and 3 because the bases are not the same. 4 and 3 are not the same. But what we can do is we can use our properties of exponents. Because both of these can be put to the negative 1/5. Is our power of a product, or product of a power. Now, our power of a power rule states that our exponents are going to be multiplied together. So we would have this here, because our powers of powers multiply. Now, negative 1/5 times 5 is going to be, well, negative 1. Negative 1, because 5 times negative 1/5 is going to be negative 1, as they simplify. Any questions on how we got 4 to the negative 1 times 3 to the negative 1? Are we good with these here? Now, according to our negative exponent rule, because we need the exponents positive, if I move it from the numerator to the denominator or denominator to the numerator, it takes the exponent from negative to positive or positive to negative. So since the 4 is negative, if I move it to the denominator, it goes to the negative 1 to the first power. Now, we don't have to write 4 to the 1 in because it's understood. We can do the same thing with 3 and move them both to the denominator. So I move them from the numerator to the denominator. And we could say 4 to the first power times 3 to the first power, or just 4 times 3. And what is 4 times 3? 12. And we get 1/12. You can try typing this into the calculator, and it should give you 1/12. Some of these will work in the calculator. Some of them are nice and actually do work in the calculator. For the graphing calculators, you're might going to have to transfer it back over into decimal form. Sorry, not decimal. Turn it from decimal into fractional form to get the answer. Okay, let's look at more of the properties of these exponents. More properties of these exponents. So next what we have is 5 divided by 5 to the 1/3. Because the bases are the same, we can subtract the exponents. Now I'm going to show you here exactly the mathematical way that we would look at this, and then we can kind of talk through another way to do this. Now, the mathematical way to look at this is because the bases are the same, we're going to subtract the exponents. So we're going to have 1 minus 5 to the 1 minus 1/3. Well, 1 minus 1/3 would be 2/3. And again, we can do that in the calculator, the 1 minus 1/3. You can't type the whole thing in because the calculator is not going to like, especially 5 to the 2/3. It's going to give you that as a decimal. But we can do 1 minus 1/3 in the calculator. Now looking at this here, well, fractional exponents are radicals, because this would be a cubed root because the denominator is 3. Now is that exponent positive or negative? It's positive, isn't it? So we don't have to move it. And it's already in the numerator, so we're done. Almost. Well, okay, 2/3. Is that less than 1? Well, yes, so we're good. That's it. Because we'd have to move it from the numerator to the denominator. And if we ended up with that in the denominator, well, we now have a radical in the denominator we have to figure out. We have to simplify out. So any other questions on that there? Okay. Let's look at E. Now, there is something special we can do with letter E. Is 42 divisible by 6? Well, it is, isn't it? Are they both to the same exponent? Right. Now, we used this before, but a product of powers, or the powers applied to both sides, quotient of powers, if two things are divided by, being divided to a power, both of them, the powers applied to it. We can go the other direction. We can say 42 divided by 6 to the 1/3 squared. I can pull that exponent out if it's being applied to both. Right? And you're looking at that, why does that matter? Yes? It makes it easier. Because what's 42 divided by 6? Because they're both to the 3rd power, we could pull that apart and do the division. Take that division to simplify it to 7. Now, powers of powers multiply. 2 times 1/3 is 2/3. So we have 7 to the 2/3. So it makes it a little bit easier if we can do that. Now, figuring out which one to do is a little bit tricky, but it's just seeing what are we doing. Okay, those are being divided. Let's see if we can simplify it. Because once we simplified it to this here, we don't have any radicals because 6 to the 1/3, that is the cubed root of 6. We cannot have it in the denominator. So this helps us solve it a little bit easier. Questions on this here? So we'll look at some more of these here. 2 to the 3/4 times 2 to the 1/2. Because the bases are the same, we can add the exponents. Now we just need to do 3/4 plus 1/2 to get our answer here. There's the book. And if we do this here, 3/4 plus 1/2 would be 5/4. And they're going to leave it as that there. Yeah, normally yes, but for some reason the book's going to take it like this here. They're going to be perfectly happy with that. Which, as strange as it is, that's what they're going to be okay with. Yeah, whatever. Now, number 2, they're going to subtract the exponents. So we're going to have 1 minus 1/4. And again, at this point here, we can't type everything into the calculator, but we can type the exponents. 1 minus 1/4 into the calculator, it would do that, which will tell us that it is 3/4. It'll tell us that it's 3/4. All right. Any questions on these first two? Any questions on these first two here? Okay, let's look at number 3. To solve this here, the first thing we're going to do is pull that 1/2 out. Because again, we want to simplify this down. So the easiest way to simplify it is to rewrite it as 20 divided by 5 to the 1/2 to the 3rd. Well, that works out because 20 divided by 5 is 4 to the 1/2 to the 3rd. Now powers of powers multiply, giving us 4 to the 3/2. And I have a feeling we're going to leave it there. Yeah. So we can leave it there, but it turns out actually you can type this into the calculator. Type 4 to the 3/2 into the calculator, see what you get. 8. Since this gave you a whole number answer, you could have typed this thing into the calculator to begin with, and it would have given you your answer. So some of these here we can type in, and it'll tell us the answer. Some of them won't. Questions on this here? We're not going to worry so much with this one. Any questions on any of these here? Okay. These here are following the same type properties of this here. So are there any questions on most of these properties that we've looked at for this here? Any questions on any of these here? Now the nice thing with some of these here, the graphing, or not the graphing calculator, but this here will simplify a lot of them for you. Okay? And I think that's actually it.